Okay, hello guys, welcome back to Shure and Neko, and today we are going to code something in Qiskit, and we are going to make a Schrödinger cat in Qiskit. So as you know, Schrödinger cat is both dead and alive in quantum state. But today in Qiskit, we are going to make a qubit that both 1 and 0 in the same time. So let's hop into the tutorial. So first you're going to need a Qiskit module in Python. We're going to import our Qiskit, and we're going to check the Qiskit version. So I'm using Qiskit 2.4.2 is the newest Qiskit. Okay, so we did open our command prompt now. We're going to go to our conda environment, type conda, activate, and your environment. My environment is called quantum. So we are going to open it, and you can install Qiskit pip install Qiskit. Yeah, as you can see, I already have Qiskit here, and we are going to start the code. Okay, so to actually make a quantum bit or a qubit, first we're gonna need a quantum circuit. So from Qiskit, we're going to import a quantum circuit. Next, we're going to make a quantum circuit. Okay, so inside this bracket there is already 1 and 1. So the first number is how much your qubit is, and the next number is how much your classical bit. So we are going to make 1 and 1, so 1 qubit and 1 classical bit. So next we are going to make the Hadamard gate. So circuit.h, and 0 here is we're going to put it in the first qubit, so it's going to be 0. And the last thing is we're going to measure it. Okay, so measurement works here. It's going to measure the 0 qubit here. So the 0 qubit here is going to Hadamard gate, and it's going to be put in the 0 classical bit. Okay, and we're going to check the circuit using draw. MPL here mean is matplotlib. Okay, so what this do is we'll make a funny image of what we make. Okay, so without this we cannot know what is going on, but if we draw the circuit we can have this funny image of what we made. So this line is qubit number 0, so this 0 1, so it's going to be measured and put into the classical bit number 0. So if we increase the number here become 2, so it's going to be have a 2 line. See, so this is the qubit 0, this is the qubit 1, and if we increase here it's going to be the same. No, it's going to be it means there is 2 classical bit here. So for example, if we measure the empty line here, circuit.measure. So if we're going to measure the empty line here, so this is mean that the qubit number 1 is going to be put inside the classical bit number 1, while the qubit number 0 will be put inside the classical bit number 0. Okay, so before we make anything much harder, let's just stay with 1 qubit and 1 classical bit. Okay, wait, this is wrong. This has to be 0 and 0. Okay, there you go. So anything come this box, it's going to be both 1 and 0 until it measure. Okay, so I'm going to explain what happened if qubit enter that edge or Hadamard gate. So imagine there is a ball or a sphere here. Okay, so we are going to place this as 1 and this is 0. So first, for example, we have a 0 qubit here. Okay, so what happened here, it's not like a coin. So what I explained before, it was like a coin in the we toss the coin and we don't know what's inside. It can be number, or it can be head, or it can be tail. Okay, so this is different than the coin. So what is happening here, the qubits start from 0. Wait, what? So it start from 0, start from here, and then the qubit just went to the middle here. Let's just call this plus, like that. Okay, so when there is a measurement, okay, so when there is a measurement, here, the qubit will collapse. So this is going to choose between 1 or 0. And the qubit will be choose it randomly. Like that. Okay, so I forgot what to do next. Okay, so next we're going to make a simulation. To make this, we're going to import again from Qiskit. Import quantum, no, import IR simulator. Okay, so we are going to make a simulation about a quantum bit that going to this system here. To make a simulation, we need to write this comment. I don't remember the syntax, I'm very sorry. So first we're going to make a variable called run. Simulator. Wait, we're going to make a simulator first. Simulator, and then we're going to make the run. Okay, so what this is mean is going to run a simulator in this circuit that we made. Okay, so the next thing is we are going to put the result. Okay, and we're going to print the result. What? Okay, so I'm sorry, it's Qiskit Air. Okay. Okay, so it's throw a lot of stuff here. I think I did something wrong. Okay, so we need to count. Count is we should get count, and we're going to print the count. Okay, so what it is mean is 548 qubit went to 1 and 576 qubit went to 0. So this is like we're throwing 1,000, not 1,000. I think we can. Okay. Shot equal 1,000. Okay, so it's just like we're just tossing 1,000 of coin and it will land into 1 or 0. So it's going to be like that. Yay! Okay, so what's the function of this? I don't know, but it's just kind of fun too, because we can flex to people that we made a quantum circuit, and yeah, I don't know what I'm doing, guys. I don't know. I'm just fulfilling my um what? Okay, I don't know. Okay, so that's it. The Qiskit tutorial, I guess. I hope you like it, and see you guys in the next video. Bye bye.